This is video 3 of looking at the C-1 notes, which is over trig identities for compound angles. So compound means that you're adding or subtracting the angles. All right, so we're going to go through problem 3 in this video. So we're going to do all 3 parts. So it says, without using a calculator, find the exact value of, first we need the sine of 15 degrees. So if you think about your unit circle, and I have a unit circle here, all right, we can see that 15 degrees is not one of the special angles that we have on our unit circle. It doesn't mean that 15 degrees isn't here. It certainly is. It's right in here. But we haven't worked out what the ordered pair is that goes with that. And we don't necessarily have an easy way to do that. So what we're going to do is try to find a couple of angles that we could either add or subtract to get 15 degrees. And hopefully this one's pretty easy. You can see that 15 degrees, we could do 45 minus 30. Or we could do 60 minus 45. Or you could even come over here if you wanted to and do, 135 minus 120. 150 minus 135. So there are lots of different ways that you can get that. But we're just going to kind of go for the simplest one. And why don't we do 45 minus 30? So let's go back to our notes here. And so we're going to write the sine of 15 degrees as the sine of 45 degrees minus 30 degrees. All right, and then we know that the sine, as we've already said, goes sine, cosine, cosine, and then cosine sine. And then remember that the sine, S-I-G-N, stays the same. So since this is minus, it's going to be minus here. And then it's going to be cosine of 45 degrees times the sine of 45 degrees. And you can go back and double check your formula and make sure that that's in the, 30 degrees. Make sure that that's in the right order. All right, so now we're going to work these out. So the sine of 45 degrees is the square root of 2 over 2. You can go to your unit circle. Cosine of 30 degrees is the square root of 3 over 2. Again, you can go back to your unit circle and double check these. And then the cosine of 45 degrees, right here, is the square root of 2 over 2. And the sine of 30 degrees is 1/2. So it looks like we're going to end up with, when you multiply these two things together right here, remember you multiply the numerators and you multiply the denominators. So when you do that on the top, square root of 2 times the square root of 3 is the square root of 6. That's a rule that if you have the square root of a times the square root of b, as long as a and b are not both negative, then that's equal to the square root of ab. And then in the denominator, 2 times 2 is 4. And then when I multiply these two together, I get the square root of 2 over 4. And now these two have the same denominator, fortunately. So the denominator is 4, and then the numerator is just the square root of 6 minus the square root of 2. And those are not like terms, so I can't do anything to simplify that. Excuse me. And you can check this on your calculator. If you put this into your calculator right here, now you do have to, when you put it into your calculator, put this in parentheses on the top and get a decimal, and then put in the sine of 15 degrees into your calculator. Make sure you're in degree mode. You should get the same thing. So you can check it and see that it works. But notice that what we have found here is the exact value. Exact means you're leaving the square root sign in there. You're not changing it to a decimal. Okay, the next one is the tangent of 11 pi over 12. So this one, again, the trick is to go back to our unit circle and to try to find the angles that will work for that. And for this one, until you kind of get used to it, I think that maybe the easiest way to do it is to think about changing all these angles into twelfths. Now, if we think about the number 11 pi over 12, all right, that's 11 twelfths is less than 1. So that means it's less than half a rotation. In fact, it's probably, it's really close to a half a rotation. It's going to be somewhere over here. Excuse me. So we want to find a couple of angles, again, that we can either add or subtract to add up to, or to get 11 pi over 12. So I'm going to just change these to 12. So this is, if I multiply the top and bottom by 2 here, this is 2 pi over 12. If I multiply top and bottom by 3 here, this will be 3 pi over 12. Here I have to multiply top and bottom by 4, so this is 4 pi over 12, and you can get the idea. This I'm going to multiply by 6, so this is 6 pi over 12. This one I'm multiplying by 4, so this is 8 pi over 12. This one I multiply top and bottom by 3, so this is 9 pi over 12. And you may already see a pair that works. Multiply by 2, and I get 10 pi over 12. Okay, all right, so now remember I'm looking for two numbers that I can add to get 11 pi over 12. And again, there are a couple of options. I could go with 3 pi over 12 and 8 pi over 12. If I add those, 8 pi plus 3 pi is 11 pi, and that'll be over 12. All right, or I could go with 9 pi over 12 plus 2 pi over 12. That would also work. I don't know if there are any others or not. Okay, you can kind of play around with that. All right, so I'm just going to go with the first one that I had, the 3 pi over 12 and the 8 pi over 12. So let's go back here. So we're going to write that this is the tangent of, and first we have 3 pi over 12 plus 8 pi over 12, okay? And I'm just going to go back to, what these simplify to. So this is the tangent of pi over 4 plus, and then this is 2 pi over 3. All right, so now using the formula, and you can go up to the formula sheet to see this. Remember that the tangent one, we get a fraction. And in the numerator, it's just basically, the tangent of this plus, because this is a plus, the tangent of this. So it's the tangent of pi over 4 plus the tangent of 2 pi over 3 divided by 1 minus the tangent of pi over 4 times the tangent of 2 pi over 3. So now we need to simplify that. All right, so the numerator is going to become, so the tangent of pi over 4 is just 1. You can confirm that with your unit circle. And then the tangent of 2 pi over 3, and you may have, again, already done this on your unit circle, but 2 pi over 3, if we want the tangent, remember, is right here. Here's our 2 pi over 3. Tangent is y over x, so it's the square root of 3 over 2 over negative 1/2. If I multiplied both the top and bottom by 2, I get the square root of 3 over negative 1, which gives me negative square root of 3. And so then going back to my problem, all right, this becomes 1 plus sorry, okay, 1 plus a negative, so it becomes 1 minus 1 plus a negative square root of 3, 1 minus, and then down here I'm going to get 1 minus for this formula, and then remember the tangent of pi over 4 is 1 times negative square root of 3, and so this is going to simplify to 1 minus the square root of 3 over 1. This is a negative times a negative right here, negative times a negative, so we're going to end up with plus the square root of 3, and that's the final answer for the tangent. All right, now for the cosine of 255 degrees, again, you can go back to your unit circle and try to, kind of play around with the numbers and see if you can get a couple of things that add up to 255. Again, you might think about where it is. 255 is going to be a half rotation, 180 plus 75 more, so it's going to kind of come down like this. So for this one, there are a couple of pairs that you could use to get 155. You could use 120 and 135. If you add those up, you get 255. You could use 45 and 210. If you add those, you get 255. So again, you can just kind of play around with that and see. So I'm going to use the first one. So we're going to make this the cosine of 120 degrees plus 135 degrees. And remember that the cosine, the pattern is cosine, cosine, sine, sine. And again, you can go back and look at the formula sheets to see that. So it's the cosine of 120 degrees times the cosine of 135 degrees. And remember that the sign here switches. So if the cosine is plus, this becomes minus. And then it's the sine of 120 degrees times the cosine of 135 degrees. And then again, it's just a matter of filling in what those values are. So I'll let you go to the unit circle and double check them as I put these in. But the cosine of 120 is negative 1/2. The cosine of 135 is negative square root of 2 over 2. Minus the sine of 120 is the square root of 3 over 2. The cosine of 135 is this should be sine. I'm having a terrible time this morning. It's cosine, cosine, sine, sine. All right, so this should be the sine of 135 is square root of 2 over 2. There we go. All right, so now this turns into, if I multiply these two together, I have a negative times a negative, so that's going to be positive square root of 2 over 4. And then minus square root of 6 over 4. So this becomes square root of 2 minus the square root of 6 all over 4, which looks kind of familiar. We've seen something like that before.